Hi, this is Alex from devstories.eu. Pulumi, Infrastructure as Code, Episode 2 of 10. You instantiate a standard Python class in your editor, hit deploy, and seconds later, a storage bucket exists in the cloud. How exactly does a local object in memory translate into a remote physical resource? Today, we are answering that by looking at under the hood, Pulumi's architecture. There is a common misconception about how this tool works. When you write a deployment script, your code does not communicate with cloud APIs. The environment running your Python, Node, or Go code has absolutely no idea how to talk to Amazon Web Services. Instead, Pulumi splits the deployment process across three distinct components: the language host, the deployment engine, and the resource providers. It starts with the language host. This component evaluates your program and extracts your intent. Consider a Python script where you declare an AWS S3 bucket by initializing a bucket object. The Python language host runs your script line by line. When it hits that bucket declaration, it does not make a network request to AWS. It simply sends a registration request to the deployment engine. It tells the engine that you want a bucket with specific properties to exist. The language host communicates this desired state over a local connection and then halts, waiting for a response before evaluating the next line of code. The deployment engine receives this registration request. This component is the orchestrator. The engine knows nothing about Python syntax, and it knows nothing about the AWS API. Its only job is state management. It looks at the desired state sent by the language host and compares it against the last known actual state of your infrastructure. If the engine sees that this exact S3 bucket does not exist in the current state, it calculates a diff and determines that a create operation is required. To actually build the bucket, the engine hands the task off to the third component, the resource provider. Providers are standalone plugins downloaded for specific platforms like AWS, Azure, or Kubernetes. The deployment engine sends an instruction to the AWS resource provider telling it to create the bucket with the requested properties. Here is the key insight. The resource provider is the only component in this entire chain that knows how to speak to the cloud. It takes the generic creation command from the engine, translates it into the specific REST API calls required by AWS, and executes them over the network. Once AWS provisions the S3 bucket, it returns a physical resource ID. The resource provider catches this physical ID and hands it back to the deployment engine. The engine updates its internal state to record that the bucket now exists in the real world. Finally, the engine signals back to the language host that the resource is ready, passing along any output properties like the bucket name or URL. The language host resumes execution and your Python script continues to the next instruction. This strict separation of language evaluation, state orchestration, and cloud execution is what gives the architecture its flexibility. You can add a new language programming without touching the cloud providers and add a new cloud provider without modifying the language hosts. That is your lot for this one. Catch you next time.